Hello guys, so in this video I'll be talking about 3D arrays using pointer notation in C and C++, and we'll try to first understand how to map or draw a 3D array, and then we'll try to um, dereference the array, like to see the different layers and to understand the how we get the addresses of the elements within a 3 by 3 array. And then we can show how we can dereference the address to get the actual value at a particular point. And we'll make a comparison between the pointer notation and the subscript notation. All right, so let's start doing that. Now, um, supposing you have something like A of 2 by 2 by 2. All right, say this is int, right? No, this here is saying that we have 2 2 by 2 arrays, right? We have two 2 by 2 arrays. Now a 2 by 2 array, right? We can draw a 2 by 2 array like it will have, in fact, let me just put it like this. If I have a 2 by 2 array, what this means, I have two 1D arrays. And each 1D array has two elements. So this is 1D, this is one 1D, this is the next 1D. And each 1D has two elements. All right, so this here is a 2 by 2 array. So the address, let's say this array name is A2 by 2. The base address, right, of this array will be the address of the first element of the array, but it will be the address of the first 1D array. So here will be A plus 0, here will be A plus 1. Then we need to dereference this to get the first 1D element here, and that's going to be asterisk of A plus 0, and you plus a 0 because it's the first element. Then you can dereference the second element here within the first 1D, right? A plus 0 plus 1. Then if you want the value stored in here, you have to dereference this address. So it's going to be like asterisk of A plus 0 plus 0 will give you the value stored here. Okay, so now we're not dealing with 2 by 2 arrays. We're dealing with 2 by 2 by 2. We're dealing with this here, this whole thing here is one 2 by 2 array. Now we are dealing with two 2 by 2 arrays. So we need to draw a next block similar to this block here with two 1D arrays, with each 1D array having two elements. All right. So let's try to do something like that. Sorry guys, give me a minute here. All right, so what I'm saying, you have this. I shouldn't draw this block. I shouldn't do this first. I should say, if I'm drawing an A of 2 by 2 by 2, it means that I need to draw two 2 by 2 arrays. So first I can draw a 2 by 2 array, and a 2 by 2 array means, again, shouldn't do that. I should start showing a 2 by 2 array is 2 1D array, right? 2 1D array, and each 1D array has 2 elements, right? This here is a 2 by 2 array. So I need to draw a next 2 by 2 array here, right? So you got 2 1D arrays, and each 1D array has 2 elements. So this will give me 8 elements, right? So this is a structure of a 3D array. Now, keep in mind a few things here now. This here is the first 2 by 2 array. So we can call this A plus 0. And this here is the second 2 by 2 array. So we can call this A plus 1. Now, these two 2 by 2 arrays makes up the entire array this is the entire array now. So this here is A plus 0, this is A. Now coming out here, this is like ampersand A, right, plus 0. Because coming out, applying outward indirection, we're gonna get ampersand. If you're going in, right, we're gonna get here asterisk of A plus 0 plus 0, because this is the first one, the array within the 2D array, or within the 3 by 3 2 by 2 by 2 array. This gonna be A plus 0 plus 1. Because this is A plus 1, this gonna be asterisk of A plus 1 plus 0. This is gonna be asterisk of A plus 1 plus 1. So what I'm writing here is the address of the this is the address of the first 1D array within this 3D array. Now remember, there are elements in here. I have values for these within here. You have, let's say, 1 2 3 4 5 6 7 8. Now we need to know this address. The address of 1 here is gonna be the address out here of this. To get to this, the 1 here, it's gonna be asterisk of this asterisk a plus 0 plus 0 is going to be the address to 1. To get the value 1, you will have to dereference this address, and that's going to give you asterisk of asterisk asterisk of a plus 0 plus 0. All right? Now, same thing for this one here. This is a plus 0 plus 0. I should put an X. How should I say this? A plus 0 is here. And when you dereference this, I can put a plus 0 out here. Yes, so let me just rerun this for you. Let's go slowly with this. The first one, the array, I have a plus 0 plus 0. So if I have to dereference to get inside here, I'm gonna have asterisk of a plus 0, right? Plus 0. This is gonna give me the address at 1. But I normally would put a plus 0 here because this is the first element within this one array. Now to get the value 1, I need to dereference this entire block here. So this is going to be asterisk of asterisk of asterisk of a plus 0 plus 0 plus 0. All right. So this is like a of, I want to write this here, a of I of j of k, right? I'm going for a of 0 of 0 of 0. You will start to see the relationship that this is going to be I, j, and k, right? So this here, it's going to give me the value 1. Now, if I can switch to some code to show you this, maybe I should do an next example before I get to some code, right? So let me try to do that. So just bear with me here. All right, I'm gonna redraw this. So I'm talking a of 2 by 2 by 2. So we're gonna draw two 2 by 2 arrays. So 2 by 2 array here. My first 2 by 2 array will have two 1D arrays. And this is my second 2 by 2 array. And This is my A 2 by 2 by 2. Now we will go back to this block here, right? In each 1D array, there are 2 elements. So we have a total of 8 elements, right? And you have 1, 2, 3, 4, 5, 6, 7, 8. Now, excuse me. So the name of the array A will be the address of the first element. Now in this case, we can think of it'll be the address of the first 1D array. All right. So A here, this is how I'm trying not to compromise this drawing and same time explain something, but let's see if I can do this. If I can do just shading here, all right? This block here is my first 2 by 2 array. This is my second 2 by 2 array, right? So let's do a different color on that. This should work. Right? So I have two 2 by 2 arrays. Now the first 2 by 2 array here, this gonna be the address of the first 2 by 2 array. It's gonna be the base address here. This is gonna be A, or you can say A plus 0. When you dereference this should be A plus 1. Now here you're gonna have asterisk of A plus 0 plus 0. This is the first 1D element here, right? And this is going to be asterisk of A plus 0 plus 1. Now, you want to have the address at 1. So you have to dereference this again. So let's try to do that outside here now. So you want to get this address here, address of 1. Let me just put it for simplicity, right? So this is going to be dereference this address here, A plus 0 plus 0, dereference will give you the address here. So this point here, I can just, this here is the address at this point here. Now if you want the value, well, when I write this dereference here, right, this address here, I can just put a plus 0 to say this is the first element here. All right. And for example, to get the address of 2, if I can write that here, it's going to be the reference of A plus 0, right, plus 0, right, and you need to put a plus 1 here, right, because you're going to the second element. Good. Similarly, if you want to get, so I'll go through back this slowly. Here's A plus 0. Here is the dereferencing of A plus 0. Then I plus 0 because it's the first element, our first 1D array. to get here, what I did was to the address of the first element here is the dereference of this, which is asterisk of everything that was here, right? Then I plus 0 because it's the first element. I want to get to the 1. What I need to do is to dereference this whole thing here. So that's going to be asterisk of asterisk of asterisk of a plus 0 plus 0, right? This is a plus 0 here, plus 0, right? So this will give me the value at a of 0 of 0 of 0, which is 1. Now, this is like I, J, and K. So this is I, J, and K. I don't know if I should just draw a portion of this so that I can re-explain this here. Like I can try to dissect this thing like this, just this portion here. So let me try that. So you can, get a good picture of this whole array business. So I'll go again. So what I'm saying really, right? If you have, I'm just gonna draw some boxes, so you're gonna get it from this. You have this one, the array. And within this 1D, you have 2 elements, right? So I'm looking here at the first 1D array, right? I'm just trying to sorry guys, this thing is a little painful sometimes. So this is the first 1D element within the 2x2, first 2x2. So I should get something like this. And then get something like this. So here was a plus 0. Here was asterisk of a plus 0 plus 0. I'm saying to get the address here, I have to dereference this whole thing here. So I'll have asterisk of a plus 0 plus 0, right? And then I add a plus 0 because this is a 0th element. This is a 1 element, right? And here the address is going to be the same as asterisk of a plus 0 plus 0 plus 1. So if the value here was 1 and here was 2, to get this 1, I will have to do a asterisk of asterisk of asterisk of a plus 0 plus 0 plus 0, that's the 0 here, right? this will give me the value 1. So you see we have a triple pointer here now, right? This here is I, this is J, this is K. In subscript notation, it will be A0 of 0 of 0, meaning you're reading from the first 2D array, and this means the first 1D array within the 2D array, so it's a 0th array, and you're reading the first element, the first element. Now, what if I have a of 0 of 0 of 1? What am I saying here? This is the first 1D array, the first of the 2 by 2 array, right? The first block, and what am I trying to tell you here, guys? I'm trying to say this 0th element, that's the first element of the first 2 by 2 array, that's this here, and the, so I should draw it so you see what I'm saying. You got your, this is your 2 by 2, and you have 1 2 1 2 1 2 1 2 1 2 1 2. This is this. When I say 0 here, I mean this block. This 0 is saying the first 1D array. This one is saying this element here within the first 1D array. This is A0 of 0, A001. Now, if I try to get this value here, what will that be? And this here will become asterisk of asterisk of asterisk of A plus 0 plus 0 plus 1 close. So what can you see here? This is I, J, and K. I, J, and K. So this will give me 2. So should I try to do a next one? Maybe I can try that. Again, let us take a random one. A of 2, right? Well, we're dealing with a 2 by 2 by 2. But if you want to read A of, let us say 0, not 0 this time. We will use A of 1 of 1 of 0, whatever is this. So what is this really? We draw our array block. You have, let me see, it's divided into two 2 by 2 arrays. So this is 1 2 by 2. This is the next 2 by 2. and each 2 by 2 have 2 elements. Now when I say A of 1, this one here, this is A, right? And this is A plus 1. This is like A plus 0. So this is a zeroth element. This is like A of 0. And this is like A of 1. So I'm dealing with this guy here. So I need to switch over here. Then within here, I have asterisk of A plus 1 plus 0 and asterisk of A plus 1 plus 1. Now this one here, I'm saying I'm reading from the, not the zeroth element, but the 1 element here. This is like 0 and 1, right? Because this portion here is a 2 by 2 array, right? So I'm reading the second element because you're going to have A of 0 and A of 1. So I'm over here, and then I'm reading the 0th element. So that's here. So how do we dereference this guy? Now, this here will become, we're dealing with, this should be a value of 7, but we're going to deal first with the address. Now, outside here of this one, the array, the address is asterisk A plus 1 plus 1. Asterisk of A plus 1 plus 1. To dereference this, to get further in, we will have asterisk of A plus 1, right? Plus 1 plus 0, the 0th element, right? Now the value 7, to get this value here, right? If I can erase some parts of this thing now. So I can write this clearly here. So this here, if I dereference this, it will become asterisk of asterisk, this asterisk, then you have asterisk A plus 1, right? Plus 1, close that. Then you have plus 0. Now, I'm saying this is equivalent to this. So what is this? This is 1, 1, 0. This is I, J, and K. So this will give me a value of 7. Alright? So, guys, I think if you go through, I'll try to show you my code now. But I'm trying here to explain how we are coming up with the pointer notation, right? From the subscript notation, how you're getting to this. One other thing I want to touch on in this video is to say that these are integers and each one of these occupy 4 bytes. You'll see in my code the address of each element is incremented by 4. And you'll see the entire array block. This 2 by 2 by 2, this is like 8 times 4, which is 32 bytes. So you will have ampersand A will be a value, whatever is it is x. And ampersand A plus 1, which will be this entire block, plus 1, that's 32 bytes, will become ampersand a plus 1, whatever that value is, if x plus 1. When I say 1 here, I don't mean literal 1, I mean 32 bytes, right? Now, I will go to my code now so that you can see what I'm saying. So, before I do that, I did run this code before, and I can show you the simulation of that. This was a 2 by 2 array. This was the 3D array, and here. So you can see a plus 0, a plus 1. I dereference this and I add a 0 because it's a 0 element, or the first one, the array within the system. Then to further dereference this, asterisk of whatever is this here, and then I plus a 0 to say it's a first element. Then to get the value here, I took this entire part here, this entire address, and I dereference it and I get the value 1. Now you can do this for every element. Just follow this here. Try to dereference, apply a dereference here, inward. If you're going in or in direction here, you're adding an asterisk. If you're coming out, you're adding a ampersand. So you see this ampersand a here. This is a starting address of the entire array block. This a is the starting address of the first 2 by 2 array block. This here is the starting address of the first 1D array block within the first 2 by 2 block, right? And here is the starting address of the first element within the first 1D array. Now, my code here will explain all of that. You can sit and churn this out and see what you're getting out of it now. All right, you what I wanted to bring across here is how to actually draw an array structure, for a 3D array, and then work your way to understand the address, right? So you can see here that I have ampersand a. This whole block is 32 bytes, and you can see ampersand a is 816 here. Ampersand a plus 1 is 848. That is an increase of 32 bytes. And each element is incremented by 4 bytes. And you can relate A00, A000 equal 1 to this here, and try to go through back how I explain the I, J, and K using random elements within the array block. But before I close this video, I will show you, I will rerun the code for this so you can see what I'm doing. Maybe I should show you my code. So remove ARR 3D v5, and now I do a cat of AR array 3D v5. That's C. This is my code. So I'm gonna go slow on the screen so you can pause the screen and you can try to run this code. Alright. There you go. You can do that. But now I'm gonna compile GCC array 3D v5.c OARR 3D v5, and now I'm gonna run it. 3D v5, and here you can see ampersand A is 840 in this case because I just compiled, rerun the code, and it increased by 32 bytes. That's an entire array block. So if you want me to take a shot at explaining back this here now, we have the entire block here, right? We have two by two arrays. So this is 2 by 2, this is 1D, this is 1D, and each one has two elements, right? So what I'm saying is that this is a, shouldn't draw this line here. This here is your first two by two array, second 2 by 2 array. This is have an address of A, right, plus 0. This is A plus 1. This is asterisk of A plus 0 plus 0. And this here is asterisk of A plus 0, right, plus 0. And then you would add a plus 0 here, all right? So maybe this is not good enough. I really want to get this point over. So why not try again? Why not try again? I have my 2 by 2 arrays. Maybe I'll be running into a lot of time here, guys. So just look at the code. Go to my explanation here. All right. You have these two 2 by 2 arrays. This is A plus 0. I dereference it here. And I add 0 because this is the first one, the array. Then I dereference this here. So I have this. So it gives me the address that is storing the content 1. To find the value 1, I dereference this here and I get this. Now you have this and you have the most recent code I ran here. And you can relate this, right? So I will stop this video here. I hope you have a better insight into 3D arrays. You can use this same analogy to come up with a 4D array by taking two 3 by 3 array and drawing some blocks, and you can work your way to find a pointer notation. So guys, if you appreciate or you learn something in this video, please subscribe to my channel, hit the like button, and look out for more videos. You guys have a great night. I would say this is all for now, and until I produce the next video. So bye.